Hey everyone, this is Nolan Martin, and today we're going to be going over the TacoParser project that I created. So just a general overview, the TacoParser program is going to determine which two Taco Bell locations are furthest apart. Those will be provided in a CSV file with a couple hundred different locations. In this project, we utilize test-driven development to check the distance between every location provided in the file. The location information for each Taco Bell was obtained by parsing through a large CSV file, which is shown here. So here we have latitude, longitude, and then the name of the location. And we're going to save those values as a GeoCoordinate for each individual location. So also in this project, I'm going to go over this later, but we did use unit testing to verify that the correct values for latitude and longitude were actually pulled from this file. And we also used a little bit of logging to implement live updates and display any issues as the program executes. So to start off, I'm going to head over to the program here. First step is we're just going to initialize the log, and it's going to display that message, which we can see up here in the top corner. So just initializing the log. Next, what we're going to do is we're going to read all lines from the CSV path, and that's going to be the Taco Bell CSV file here. You did see this already, but again, in case you forgot, it's latitude, longitude, and then the name of the Taco Bell location. So what we're going to do here in the program then, we're going to print out just a sample line. So if you're curious as to what it looks like while it's running, there's just a sample line that's printed out. And then we're also going to send out a begin parsing message to view as well. So when we begin parsing, what we're going to do is call on our parse method and use that and store all of these locations in an array. So if we go over to the TacoParser tests, what we did here was we parsed the latitude and parsed longitude using the XUnit NuGet package. And what we're going to do here is check that the parse method that we're calling on in our main program right here is actually working as intended. So what we did here was using theory and inline data to check that. So for here, what we're doing is arranging. So we're going to create a new TacoParser object, then we're also going to act. And what we're going to do is call on the parse method that we created in our TacoParser class here. And then we're going to assert equal to check that when we call on our parse method, we're actually getting the correct longitude value. So what we did when writing this was we followed the red-green refactor method. So essentially in the TacoParser class, this method here, the parse method, was initially empty. So then when we decided to run all these tests, the first step was making sure that we didn't see any successes. Here, once it loads in a second, you're going to see that it is all green. But when we started, made sure that the TacoParser parse method was actually empty and returned no successful solutions. So in this using theory and inline data, what we did was provide a couple values here and an expected value out of that. So for parse longitude, given this line from the CSV file, wanted to make sure that this was the actual longitude that was pulled out, which is demonstrated through the assert equal line. So that's how we were verifying that the correct values were pulled from the CSV file. And then, yeah, so when we called on that parse method, what we did was we split the line by commas. So here, if we go back to the CSV file, I ended up splitting up each line by the commas. So that'll give us our latitude, our longitude, and then the name. So that's what we're doing here in this parse method is we're storing the latitude and the longitude for the different cells that come out of that split operation. So, and what we're going to do with the latitude and longitude is save that to a new point. And that's how we have the GeoCoordinate for the Taco Bell locations. So we go back to the main program here. So now that we parsed through and grabbed all the GeoCoordinates for those Taco Bell locations, what we're going to do is use a nested for loop inside of a for loop. And that's going to go through and assign a value to the latitude and the longitude for each Taco Bell location. And then down here, we're going to use from the GeoCoordinate package the get distance to and compare the distance between location A and location B. And the final check is going to make sure that the distance between A and B to see if that is greater than the initialized distance. So the distance was initialized to be 0. However, that is going to change as we parse through the file and grab locations of Taco Bells that are further and further from one another. So as we check every location relative to one another, we're going to make sure that we have the maximum distance being saved to the distance. So what we did here as well is include some more logging. So whenever a new max is found, we're going to print that out and state that it was found. So if we look here, new max distance was found. So those two are pretty close together. And by the time we get to the end of the file, quite a few maxes were found, but we do end on the final max, and that's going to be our final answer. So all we did at the end was display the two different locations' names and state exactly how far they are in miles. And that pretty much sums up the project. So thank you guys for watching. If you have any questions, feel free to shoot me a message. Thank you very much.